All right, good evening. All right, we'll continue with the next part. So we've seen two cases whereby it's just basic introduction to probability. And the second part was all about mutually exclusive events. All right, okay, now the third one is called independent events. Okay, so under probability, you also got a concept called independent, whereby two events, normally it's two or even more events happening at the same time, but they do not influence each other. Okay, so we take an example. All right, so let's say example. Okay, we have two marbles being picked. So two marbles are picked from a box, of three colored marbles with a green, a yellow, and a red marble. Okay, what is the probability of picking a yellow and then a red marble? So we are looking at a yellow marble first, followed by a red marble. So here we are actually picking two marbles. Okay, now the condition is after the first pick, the marble is returned to the box. Okay, all right. So in this case, so let's say that's the box. I've got one green, one yellow, and one red marble. So the condition here is we want two marbles to be picked. Okay, so they want us to pick a yellow and then a red marble. So two picks. One pick we want yellow, the second pick we want red. Okay, so that means now what's going to happen? So to pick a yellow marble, okay, and then a red. Okay, marble. So this will be, okay, we're going to pick a yellow. So we've got one of each. So my total here is 3. So the number of marbles in my sample space, which is the box, is actually 3. So we pick a yellow. A yellow will be 1 out of 3. Okay, after we have picked one yellow marble, we actually return the marble back to the box. So now the number still remains unchanged, so it becomes 3 again. So now to pick a red marble, so it's again 1 out of 3 marbles. Alright, so independent events, one does not influence each other, so we multiply. So what we actually get is 1 over 9. Okay, alright, so in conclusion, when we have two events happening and they are considered independent to each other, okay, so we use the symbol A intersection of B. This will become P of event A times P of event B. All right, okay, so this is the concept when you have two events happening independently. All right, okay, another way of illustrating this, okay, you can actually call this a tree diagram, okay, which actually looks like a tree. So basically it's just a simple diagram with very simple lines to represent the branches. Okay, so this is my first pick, so I put it as 1. Okay, then this is my second. All right, okay, so in my first pick, so the number of branches will represent the number of outcomes that I have. Okay, so what I can do is I can actually pick a green marble or a yellow marble or a red marble. And for my second pick, same thing, because all the marbles are actually returned, so the colors remain the same. So I can actually have a green for my second pick. I can actually have a yellow, or I can have a red. Okay, likewise here, even for this one, I can have a green, I can have a yellow, I can have a red. And for the third one, is also the same. I can have a green, I can have a yellow, or I can have a red. Okay, so if I'm going to list down my outcomes here, okay, my outcomes of picking two marbles, so I can actually have, the first outcome is actually green and green. Okay, actually I have green and green. That's my first pick. Second pick is I can have green and yellow. That's my second outcome. Third one, I can have green and red. Okay, the fourth outcome, it can be yellow first and followed by green. Next one is yellow followed by another yellow. This is possible. Why? Because the marbles are actually returned to the box. Okay, next one can be Y followed by red. Okay, next one can be red followed by green. Next one is red followed by yellow. And the following one is red followed by red. So if you total all this up, how many do you have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I've got 9 in total. Okay, so like just now the question, we are actually looking for yellow followed by red. So all you do is you just check yellow followed by red. So this is what I'm looking for. Okay, so yellow here is 1/3. This is also 1/3. Okay, how do I get 1/3? Okay, now this one follows the branch. I've got 1, 2, 3 branches. So 1 is actually 1 out of my 3 branches. So this is also 1 out of 3. This is also 1 out of 3. Likewise, all these branches, this is 1 out of 1, 2, 3. So it's 1/3. This is also 1/3. This is also 1/3. So all of these are actually 1/3. Okay, 1/3, 1/3, 1/3. So now if I'm looking at this yellow followed by red, if I'm going to use this as my method of solving, the probability of picking a yellow marble followed by a red marble, okay, so this one will actually be 1/3 for yellow here, this one, and the red marble, which is from here, so this is also 1/3. So it's 1/3 times 1/3 gives me 1/9. So this 9 and this 9, see, it actually tallies because this is your number in your sample space. Okay, so this is one example of how we calculate probability of independent events. Okay, so for an independent event, this one will follow. We actually follow this rule. The probability of these two events, PA and B, equals the probability of PA times the probability of event B. Now, what if you have three events? So if it's 3 events, if they are considered independent, A intersection of B, sorry, this is again intersection, this is B, intersection of C, so this will become P of A times P of B times the probability of event C. Okay, so it works for any number of events so long as they're independent, they actually abide this rule. All right, thank you.